Once again, we've got the Acuity AP820-60. In this case, with this sensor, and this has a 60 millimeter depth of field, and the laser line starts at roughly about 30 millimeters in length. Normally, we would use a larger laser line to get more of the profile of the bowling pin, but for this application, we're going to try one of the higher accuracy ones and see how they do. And so here you can see that we are getting very good signal off it, and as I move it through here, you can watch the profile of the part until we fall off the very end. And as we come back in, you can see once again that we're measuring that radius and the curvature very accurately. And of course, with that, as we zoom this up, you can kind of get an idea of the resolution of the sensor of the data we're collecting. You can see very accurately. And let's just go back in and set that up again. So as you can see, we're getting very good measurements, and if we come in here and let's try the circle fitting, and we're going to add this new measurement. And we're going to set this up to basically measure the diameter or the radius of this part. And we're just going to draw the box of where it's going to be at. And here you can see over on this section of the screen that we're getting about 57 millimeters in radius. And if we wanted to, we could come in here and we could zero that out, put in a known number, or we could also multiply it to get so it will measure that diameter pretty accurately. And just to also show that a little bit, let's put on a results screen. And let's just put that up here. And here you can see we're talking about that 57 millimeter. And as I move this down, you can see it's getting bigger as we hit that big section. And as we come down, it's measuring that radius. And we just need to move my box here to include that. There we go. So it is actually making those radius measurements very accurately. And as you can see on right there on that circle fitting, it's taking that radius and forcing a circle to it. And it's possible to get a real accurate diameter, especially with, lasers are very, very repeatable, so that if we did have what I call a golden master, or a pen that you knew exactly was to your specifications, then you could put this in, you could scan over it real quickly, and then basically calibrate to that one part, so that you could verify that the laser would be very, very repeatable. Now let's go ahead and take a look at what that 3D effort would look like. Let's go ahead and stop this. And let's look at that 3D view, and let's clear that. So now we're going to take a look at this 3D image. And here's our little graph we've got. And as we scan this, you're going to see that we're building that model. This is some of the just some of the intensities where they've gone out of range, but you can see real quickly that we are capturing that surface very accurately, especially if I sort of rotate that. You can see where those little this is a little noise from just being off the target. And if we had a longer laser line, then we capture obviously more of that surface. And let's just zoom that up a little bit so you can see some of the data that we're getting. So it is capturing it very good, and let's just go ahead and save this. It's a binary file, so we can come back and look at it. And let's also export it as a CSV file. So I can see that the sensor is doing a very good job, and with the correct mechanical fixturing, we should be able to do a really good job on making this measurement on this target.